Okay, this is take 2 because I did the question and then I realized that I was talking and then I was writing and you couldn't see a thing I was writing. So that's not useful at all. So anyways, let's do this again. Okay, so we're on question 4, guys. We are on the last question of this paper, which is fantastic. We're making great progress. So let's just jump in and see what we can do. Okay, so the Republic of South Africa conducts household censuses, I think that's how you say it, to collect information. The next census will take place in 2021, which is actually next year for us. Goodness, eh? Census information regarding household size is shown below. So it's basically got different households, right, of different sizes, different number of people, and basically the percentage of the population in 1996, 2001, and 2011. What's important, right, is these percentages represent parts of different totals, right? So this 36% is 36% of 8.7. And this 33% is 33% of 10.8. And this 25 is 25% of 14.5. So they represent different percentages, different parts of different totals. That's very important, okay? So then it says, a census is an official count or survey, okay? That's just to give you a bit of context in case you didn't know that. And then here it says, according to Stats SA, a household consists of a single person or group of people who live together for at least 4 nights a week, okay? Who eat together and who share resources, okay? Cool. That's just a little bit of background. Let's just jump into the question. So it says, use the data above to answer the questions that follow, okay? So it says, determine the percentage. That's important, right? Because it's telling us in what form they want the answer, okay? Increase in the total number of households from 2001 to 2011. Okay, so what we're going to do is we are first of all going to write here, and I'm going to make sure you can see this time, because last time I don't know who I was teaching. I was teaching myself apparently because you weren't seeing anything. Okay, so 4.1.1. Okay, so let's just see. In 2001 there were 10.8 million people. Okay, and in 2011 there were 14.5 million people. So what we want to know is we want to know what was the increase between these 2 years. So we're going to say 14.5 subtract 10.8. And if you put that into your calculator, okay, it is 3.7 million. So there was an increase in 3.7 million people between 2001 and 2011. Okay. But the question, remember, and this is important, hey, it says determine the increase in a percentage form. We've shown it in absolute form, right? By absolute, I mean an actual number form that isn't a percentage, okay? So what we have to do to get it into a percentage is we're going to say 3,7, right, the increase over the amount of people we had in 2001. Now, you might be saying, well, Margs, like, why is it not over 14.5? So the reason it's not over 14.5 is because the question asked us, right, what was the increase in the total number of households from 2001 to 2011? So 2001 is our base, right? That's where we started. And we want to know how much did 2001 increase by to get to the number of people in 2011, okay? So what we're going to do is we're going to times it by 100. You might be saying, why am I doing that? Because remember, they've asked for us to do it as a percentage, okay? And timesing by 100 helps get that percentage, okay? So I'm going to divide by 10.8 and times by 100, okay? And that gives me 34.26%. The reason it's 26 is because I rounded it off to 2 decimal places, right? That 9 is larger than 5, so therefore I round that up to 6. So it's 34.26%. So over 10 years, guys, the population increased by 34.26%. People be having all of the babies, or they're living really long, one of the two. Okay, let's now look at 4.1.2. So 4.1.2 is a compound question. It's got 2 subsets, right? And it says, state which household size, right? So it's talking about 1, 2, 3, 4, 5 or more, matches each of the following trends. Okay, so it says, which household size increased every year, but only by a small percentage? So we see here that the household size of 1 increased, but quite drastically, right? That's 11% over that time. Here it increased 1% over each of the censuses. Here it stayed the same. Here it actually decreased. And here it also decreased. So increased every year, but only by a small percentage, I would say would be a household size of 2, right? Households of 2. Okay. So what they're, oh, that's not that right. So what they're asking us to do here, right, is they're asking us, okay, they're asking us to basically tell them that we understand, or display to them that we understand what data has been given to us, okay? So let's look to the next question. So it says, which household size remained constant in every census from 1996 to 2011? And we can see that that is household 3, right? It stayed 15% the whole time. If this household 4 had stayed 15% in 2011, it would also be, but it actually decreased, right? So it has to be households of 3. Okay. So those are not really maths questions necessarily, but they're interpretation questions, which are important, right? You are showing your marker that you understand what's going on. Okay. So let's do 4.1.3. So it says, it was stated that the percentage of households with 5 or more people decreased from 2001 to 2011. Therefore, the number of households with 5 or more persons decreased by 0.060 million. Verify showing all calculations whether the statement is correct. Okay, so what we're going to do here is we're going to work out what 33% of 10.8 million is and what 25% of 14.5 million is, and see what the difference is in the number of people. What's important here, right, is that 33% of 10.8 million is very different from 33% of 14.5 million, right? So just because the percentage has decreased doesn't mean that the number of people, right, has decreased, because they're percentages of different totals, right? It's like me saying to you, I want 25%, right? I want 25% of one pizza, right? So 25% of a pizza, right, is 2 slices, right? But what if I said to you, I want 10%, right? I want 10% of 10 pizzas, right? So if I said to you, let me just write it over here. If I wanted 25% of one pizza, that is 2 pieces. But if I asked you for 10% of 10 pizzas, right, I would get 8 pieces. Do you see that? Right? So just because my percentage has decreased doesn't mean the amount of pieces that I get has decreased, because it all depends what that percentage is of. Okay, so let's do that question over here. Okay, so we're going to say 33% times 10.8. Okay, I'm just going to make sure you can see it this time, otherwise I'm going to have to redo the whole video all over again. Okay, that's for 2001, and then we say 25% times 14.5 for 2011. Now, put that into your calculator. Okay, 33%. Sorry, I think I got hiccups. Goodness. Okay. Oh, goodness. What am I doing? I must type nicely, Marks. Okay. 3.564 million. That's in 2001. Okay. And then let's do it for... Oh, goodness. Goodness. Stop that. Okay, cool. That is the number in... Right? That is the number in 2011. So what we actually see here is exactly what I showed you with those pizza pieces, right? It's just because the percentage has decreased doesn't mean the number of people in that category have decreased. It's actually increased, right? And let's figure out how much it has increased by. Okay. So the number of people has increased by 0.061 million. So the answer here, we would say they're incorrect. It's an incorrect statement that was made, right? It's incorrect. And the reason it's incorrect is because the number of people in the 5+ category has increased, not decreased, okay? And it's increased by 0.061 million, okay? So that's really important, really, really important. They're wanting you to display that you understand the percentages and absolute values are different things, okay? So let's now move on to the next question. And let me just move this up so that we are all on the same page, okay? So it says, explain why the percentages for the 1996 census do not add up to 100%. Oh, okay, let's see if they don't. Let's just add them all together. Okay, so I'm going to say 16 plus 17 plus 15 plus 15 plus 36. Let's just see if I type that in right. Okay, so they add up to 99, right? I've got 99 problems, and they seem to all be in the census. But what I mean here, right, is what's happened is there's probably been some sort of rounding, right? So maybe the 16 was like 16.3 and the 17 was like 17.2 and the 15 was like 15.1. So what's happened is we've rounded down each of these values. And then what's happened is because we rounded each of them, right, our answer doesn't add up to 100% because of those rounding errors. So the answer here would just be rounding. You can say rounding off, or you can say rounding errors, whatever makes more sense to you, okay? So that's what, they just want you to understand, right? And this is something that they said at the beginning of the paper, right? Which I harped on about earlier, is I said, we don't round off until we have finished the question, right? And that's the whole reason, right? You don't want to round off until you finish the question, because otherwise sometimes your answer doesn't actually account for everyone, right? And it's slightly off. And you want to be in maths, right? The importance of maths is to be as exact as possible. Okay, so that's that question. Now, let's move on to the last question of question 4.1, and that is 4.1.5, and says, write down the probability of randomly choosing a household from the 2011 census, important, right? With a household size fewer than 4 persons, okay? So it basically wants these guys, okay? So 1 to 3, because that's fewer than 4, right? So we can't include 4 because 4 is not fewer than 4. It's equal to 4, okay? And remember, with probabilities, right, it adds up to 100%, okay? So what we're going to do here, right, and I know that I've done this before, but I'm going to do it again. Probability, the way we do probability is we say probability, we put on top the events we want, right? Over, so I'm going to say events wanted, okay? Over possible events, okay? And the events we want, right, are 27 plus 19 plus 15. These are all percentages, right? Those are the ones we want, the 27, 19, and 15. I'm going to put that over 27 plus 19 plus 15 plus 25. Oh, I forgot the 14. Sorry. You have to put it over all the possibles in 2011. So you add all of those together. Okay. Then we put that into our calculator. Okay. So we say on top, these are the guys we want. We want fewer than 4. But we could get, if we just randomly chose, we could get anything, right? We could get anything from any category, including above 4. Okay. So it would be 0.61, okay? And you can make this a percentage if you want to, right? You times that by, you say that times by 100. So it is 61% probability, okay? So remember, with probability, we're saying, what do we want, right? What do we want? These specific events over all the possible events. The possible events also include the events we don't want to happen, right? And then we get the probability, right, of getting the events we want, which is 61% in this case, which is actually not a bad probability. It's greater than half, which is pretty good. So that is that question done. Okay, we are now going to move on to 4.2, and then we have 4.3, and then we are finished, guys. We are almost there. Okay, cheers.